to talk about today is on the backside, matrix multiplication, because we're going to need it later on in the chapter in another method for solving systems. We're going to need to multiply matrices. So a couple of quick reminders just above that top box is the matrix is named with capital letters. So in this unit, when you see those capital letters, that's talking about matrix A, matrix B, etc. The order of the matrix is your rows by columns. So make sure that you know that. And then we call the individual parts or numbers inside the matrices entries. Okay, so I'm going to be using some of those words, order and entries. Make sure you know what I'm talking about there. Okay, so we're going to start with something that's pretty basic, matrix equality. And so notice I have capital letters A equal to capital letter B, so that means matrix A equals matrix B. What would you say would have to be true if two matrices were equal? The entries are equal. They're basically like the same matrix, right? So I'm going to say here two matrices are equal if their corresponding entries are equal. So I think, Liam, you said entries are equal. We're going to put a little qualifier on their corresponding entries, meaning if it's the first row, third column entry, it has to be the same as the first row, third column entry in the other matrix. It can't be jumbled around. Okay, they have to be the same. So knowing that, can you solve for x and y in the two matrices right below? So I'll just give you a moment to kind of look those over and see if you could solve. What is x? What is y? If those matrices are set equal to each other. If I were doing a problem with matrix equality, I would focus on where my unknown is, what I'm trying to solve for. So if I'm trying to solve for x plus 1 is in the first row, second column. So x plus 1 has to be the same as first row, second column in the other matrix. Therefore, x plus 1 equals 3, x must equal 2. And same process for y. Y is second row, first column. Therefore, it equals second row, first column in the other matrix. 2y equals 4. Y is also 2. Now, in this example, I won't write my answer as an ordered pair because it's not representing a system of equations. It's just like two unknowns. Later on, you'll see, like, whenever we're doing systems, we'll have ordered pairs, ordered triples. Okay? And it wouldn't bother me if we wrote it as an ordered pair, but it's not really an ordered pair. Okay, matrix addition. Does anybody remember from Algebra 2 what must be true about matrices before you add them? Oh, sorry, you're just all whispering. They have to have the same order, okay? Matrices can be added if they have the same order. So if you're being asked to add two matrices that don't have the same order, their sum is not possible. So homework, quizzes, tests, if you're ever asked to add two matrices that don't have the same order, you can just write not possible and move on. You don't have to do any kind of work. And the reason why that's not possible is we add matrices by adding corresponding entries. Okay, so remember we talked about corresponding entries up there with matrix equality. So that would mean they have to be the same order so that every entry in one matrix has something to add or subtract with in the other matrix. If they don't have the same order, some entries won't have anything to do, and that's not possible. Last thing we want to talk about just really quickly is scalar multiplication. A scalar is different than matrix multiplication. We're just multiplying like a number, C, by A. And in order to do matrix multiplication, you multiply every entry. By the scalar. So I often think about scalar multiplication just like basic distribution. If I'm going to do 2 times matrix A, I have to multiply 2 by every single entry in matrix A. So it affects all the entries. You've got some problems down at the bottom of the first page, so go ahead and work them out. I have full confidence in you. You can talk to your group members if you need to. I'll give you some time and then I'll put my answers on the board. Let me know as I'm walking around if you feel like you have a question, you're not sure where to start. So I've got my 3 solutions on the screen. All of these were possible. We're working with 2 3x3 matrices, so we can do all of the addition and subtraction. They have the same order. Double check my math, make sure I didn't miss any signs or anything like that. What would you warn somebody about? Like they should be careful on that last one. What are some pitfalls for people? The negative signs, the fact that you're subtracting, that you've got to subtract every single entry. So, and be careful, like on that second row, second column, 0 minus -4 is really 0 plus 4. Same for second row, third column, -3 minus 3 is -6, not 0. One thing you can do with matrix subtraction is if you want to change it to addition, then just change all the signs of the numbers in the matrix after it, okay, so that you don't have to worry about that. Any questions or concerns about adding, subtracting, or scalar multiplication? Okay, not bad, right? Can you imagine how you could do this in your calculator? Type in matrix A, 3x3, save it in matrix A, type in matrix B, 3x3, save it in matrix B, and then go back to your computation screen and pull up A plus B. Okay, you'd have to go to your matrix menu and get your A plus B, your A and your B from your names menu. Okay, but you could do it in a calculator. Okay, next up, we're going to talk about matrix multiplication on the back. Again, this is probably the most important part because we're going to use it later on in the chapter to solve systems. Does anybody recall from Algebra 2 or Algebra 3, like what is special or what needs to be true in order to do matrix multiplication? Dylan? The number of columns in the first one has to be equal to the number of rows in the second one. Liam, were you going to say the same thing? Yeah. Okay. Some people that remember from Algebra 2, like the two middle numbers and the orders have to be the same. Okay, so that's basically what I'm going to put here at the top. Let's suppose matrix A is m by n, and I could choose any letters for the order that I want, and B is n by p. Then, going along with what Dylan and Liam agreed to, the columns in the first matrix have to equal the rows in the second matrix, so those middle two values would have to be the same if I were going to do A times B. And then that would be m by p for my answer matrix. Now, I use that order for my answer matrix to help me and hold me accountable to that I have all the entries in the answer matrix that I need. Okay, so I'll talk about that when we do our example together. And then in the second part, the paragraph is kind of describing what you're actually doing with matrix multiplication. The key piece that I would say to you, really focus on and make sure you know when you're doing a matrix multiplication is essentially row by column matrix, or multiplication, row by column multiplication. So if you're multiplying A times B, you can take the rows in the first matrix A, multiply them by the columns in the second matrix B. So you gotta really stay focused on row by column multiplication. It describes taking the ith row and jth column of the product, and here's how it kind of works. You multiply the entries of the ith row by the corresponding entries in the jth column. So that means if I have a first entry in my row, that multiplies by the first entry in my column. The second entry in my row multiplies by the second entry in my column. Third entry in the row, third entry in the column, right? Just keep going. And then all those multiplies you add together, and that's one entry. And so there's a sum. You add the results. Okay, let's put that to work. Now, on this example, I'm going to show more work than a lot of people will normally show, but because it's our notes, we want to be able to tell where our numbers came from later when we look back at this, so it's a good idea to write down the work. Okay, so first thing I would do before I do matrix multiplication is double check that it's even possible. So check your orders. What's the order of matrix A? 3 by 2, 3 rows by 2 columns. In the order of matrix B? 2 by 2. Am I allowed to multiply those matrices? Yes, columns equals rows in the second matrix. What will the order of my answer be? 3 by 2. So that means I have how many entries in my answer matrix? I have 6 entries, 2 in each row. Okay, and I have 3 rows. So I'm going to start my 3 by 3 matrix right here. Or sorry, 3 by 2 matrix. My apologies. And then I'm going to start that matrix multiplication that we first described as row by column. Okay, so I always start with the first row, top of my matrix. And I'm going to take the first row times the first column. And then I multiply the corresponding entries. So in each, the row and the column, I only have 2 entries, right? So I'm going to do -1 times -3, because that's the first entry in the row times the first entry in the column. And I have to add it with the product of the second entry in the row times the second entry in the column. So that would be 3 times -4. I usually work my matrix multiplication, I always do rows. So I'm going to complete my row. I just multiplied the first row by the first column. Now I need to multiply the first row by the second column. So I'm going to take -1 times 2 and add it with 3 times 1. So when you multiply the first row by the first column, you get the first row, first column entry in your answer matrix. When you multiply the first row by the second column, you get your first row, second column entry of your answer matrix. Now, I'm going to go down to my next row. Okay, so I did everything I could with -1 and 3. Multiplied it by column 1, multiplied it by column 2. Now I'm going to go pick up for -2. So I have to repeat it. I have to take 4, -2 times that first column, -3, -4. So that's going to be 4 times -3 and negative plus -2 times -4. And then I have to do 4 times 2 plus -2 times 1, or the second row times the second column. Are we okay with my work, like where my numbers are coming from? So I have one more row to go, right? I've done -1, 3. I did 4, -2. Now I got to grab 5, 0. Okay, multiply 5, 0 by the 2 columns. So I'm going to have 5 times -3 and 0 times -4. And in my second column, I'm going to have 5 times 2 plus 0 times 1. Now, the one thing I like about writing out this work is that I noticed some patterns. If you check your rows in your answer matrix, the first number in your product should match the numbers in the rows. So like -1 and 3. See I have -1 and 3? -1 and 3. And then I have 4 and -2 in the second row. And then I have 5 and 0. Okay, so those things match by rows, okay, from left to right. And then if you look at the columns, the first column is all -3, -4, right? And the second column is all 2 and 1, okay, which matches the columns in matrix B. So it's a nice way to see the organization if you're having trouble with like what I should be multiplying. So now we can simplify that by doing the multiplication and adding the products. So I'm going to go ahead and put my answer down here. So that will be what? 3 minus 12 is -9. -12 plus 8, -4, -15, 1, 6, 10. And it is 3 by 2. Okay, so I'm going to have you do the next multiplication there on your note sheet. If you're having trouble seeing multiplication, if like the board is too far removed from you, I totally get it. So as I'm walking around, stop me and I'll help you kind of see like what you're actually multiplying. Okay, so go ahead and see if you can get the answer. Check if you can multiply it, then see if you can get the answer. Okay, so something super helpful on like your quiz and your test when you're doing these multiplications is maybe if you don't want to write down all the work, like the individual numbers that I did in the last one, writing some kind of numbers, like what you're getting when you're multiplying before you add, that can help so I can see where you got your numbers. So I would first check if I could multiply 2 by 3 and 3 by 2. The answer is yes, and I'm going to get a 2 by 2 matrix. So I'm going to have 4 entries. To get my first entry, I'm going to take the first row times the first column, so that's 1, 0, 3 times -2, 1, -1. And these are some good work that you can show that's not too painful. 1 times -2 is -2, plus 0 times 1 is 0, plus 3 times -1 is -3. And then take 1, 0, 3 and multiply it by 4, 0, 1. So 1 times 4 is 4, 0 times 0 is 0, and 3 times 1 is 3. Since that was my first row times my second column, that'll be my first row, second column entry in my answer matrix. And then move down to the second row, I will get -4 plus -1 plus 2. And then multiply it by the second column, that'll be 8 plus 0 plus -2. So that's an easy way for me just to kind of check, like if you don't get the same entry as me, I can kind of give you guidance on where you made your error. It's probably computational. And then we should have -5, 7 for our first row and what, -3, 6 for our second row. Now, there is one final question for you to think about here. Is matrix multiplication commutative? Can someone describe to us what commutative means in multiplication? Yeah, change the order and it's the same thing, right? So like 3 times 5 is 5 times 3. They're both 15. So we just did A times B. We're wondering, is B times A the same as A times B? Without multiplying it all out, does anybody have an answer for us? Is it commutative? The answer is no. What's an easy way for you to tell that that's a no? Checking the orders. Like before you even get into multiplying B times A, what is that one? 3 by 2, and then you'd be multiplying it by a 2 by 3. Okay, so you can multiply them because the columns of B match the rows in A's, but then you're going to get a 3 by 3, which can't be equal to our 2 by 2 matrix. Okay, so the answer is no. Now, could you imagine that maybe there exists some matrices out there where A times B is the same as B times A? Yeah, so it is possible. It might mean something special when that happens, okay? And so we might see that later on in the chapter. Okay? So you do have a homework assignment that goes along with this. It's on your gold sheet. I'll put it up in just a little bit when you get started on the quiz. But work on that over the weekend. I think it's like 10 or 11 problems. It's adding and subtracting. You can attempt them without a calculator, and then if you want to check them, you could try working in your calculator just for good calculator practice. Before we get started on your quiz,